If you have a printer with an old flatbed scanner, you could be sitting on a gem for your CAD workflow. Scanners on these printers have been used to copy documents and send faxes, but we can repurpose them to help us design parts for our projects. To demonstrate this, I'm going to use a simple example for creating a wall mount for my Amazon Alexa. To pull this all together, all we need is a CAD application like Fusion 360, a printer with a flatbed scanner, and a measuring tape. Once the print is set up, place the Alexa onto the flatbed scanner in a position where it can be seen and it's not obstructed. Next, take the tape and place that face down, also in an area that can be clearly seen. Place something heavy on top of the tape to stop it from moving around during the scanning process. Using a scanning utility, scan the objects on the bed of the printer. Here I'm using the default scanning utility from the Windows Store. Next, review the scan. If any objects are not clearly visible or the tape is not clearly readable, reorganize the items on the scanner and scan again. Now we have a scan that we're happy with, we need to save it onto the computer so we can access it via the CAD application. But why is this process any better than taking a photograph? With a camera, all the light is focused onto a single point, meaning that you get obvious perspective. Whereas a flatbed scanner captures the image in a series of parallel lines. This means there is no perspective in the captured image. This is perfect for when you want to start modeling on top of the image and you don't have to compensate for any optical distortion. Now that's out of the way, let's bring the image into Fusion, where we can use it to start modeling our bracket. Once inside Fusion, we need to set up our project. And to do this, we insert a canvas. The canvas is going to be the scan that we did previously. When inserting the canvas, select a file from the computer and browse to where you saved the file. Once loaded, we now need to calibrate the image. To do this, right-click the canvas from the tree view and select Calibrate. Now, using the tape that we put on the scanner, select 2 points which are a reasonable distance apart. Remember, the further apart you choose the points, the more accurate the calibration will be. Next, type in the value of the distance between the 2 points. Once you click OK, your image should now be calibrated. All that's left to do before we start modeling is to rotate it and place it in a position that is convenient for us. We can now start to sketch on top of the canvas, knowing that we're calibrated with the object. Now, depending on how you set your canvas up, I can either draw a center circle in the center of the image because it's aligned with the origin, or I can use the 3-point circle to closely click around the object to find the center point. From there, I'm able to build up the bracket, ensuring I have a sufficient tolerance around the object itself. Now all the modeling is done, it's time to send it off to one of the printers in the farm. Once the printing is complete, it's time for a little bit of cleanup and attaching to a French cleat system that I've got here in the workshop. The Alexa fits perfectly and can take pride of place on the back wall of the workshop. Now, admittedly, this is a simple project to demonstrate the theory behind the technology, but you can use this to design some really complex objects. This could be tracing a circuit board to build an enclosure, or another example that I've got where I repaired a refrigerator door where the retainer got snapped in half and taped back together. Using this method, I was able to print a replacement that fit like a glove. This isn't only limited to using with 3D printing. You could also digitize a gasket set and then laser cut it out of gasket material. If you can fit it on the bed of the scanner, then the options are pretty much limitless. So if you've used this method, why not post down in the comments what you made and how successful you were? If you found value in this video, why not hit the subscribe button and check out one of these videos just here.